In this video, we're going to talk about similar polygons. Let's start with our definition. Polygons with the same shape but different sizes are called similar. For polygons to be similar, corresponding angles must be equal and corresponding sides have a constant proportion. Notice that the rectangles below all have equal angles because they're all right angles. But if I were to look at the ratios between the sides, I can see that they wouldn't all be the same. So I just want you thinking as we start this that not all polygons are going to be similar. Just because I have triangles doesn't mean they're the same. Just because I have rectangles doesn't mean they're going to be similar either. It really has to do not with just the shape, but also how that shape corresponds to the other one. So there has to be this correspondence we set up. So let's look at some examples to really understand what's going on. So here's our first one. I gave you two different rectangles, A and B, and I have dimensions 42 and 80, and I have 36 and X. So what we know is similar polygons have a constant ratio between sides. So this means if we were to compare the length to the length and the width to the width by dividing, we should get the same ratio. So let's check this out for this one. So let's say I did the length to the length. That's 80 over 36, both in centimeters, so you can see the centimeters there. And then I took the widths, which were 42 and X. To solve this ratio, I want to cross multiply. So I'm going to have 80 times X is 42 times 36. So I'm just going to keep showing you the small steps as we go. So I left the 80 times X on the left, and then I multiplied 42 by 36 to get 1,512. I'm going to divide both sides by 80, so it just gives me X on the left. And on the right, I can simplify one more step, and it says I have 18.9 centimeters as my final answer. All right, so let's try it again. Let's switch our shapes up. So this time I gave us triangles. And this time I did make there be two missing sides. So on one part, I have this X that's missing, which is the height of the smaller one. And on A, I left the diagonal off. All right, so what we want to do here is look for what do we know. I have an 18 and an X, I have a Y and a 13, but I have a 7.5 and a 5. I really want to start there by saying I have these two I know. That will set up my beginning proportion, so I'm going to have 7.5 over 5. We need to solve for X, we need to solve for Y. You can see I wrote down Y first. So you can see here I have Y over 13. Okay, so I did big to little, big to little. You just have to be consistent. It doesn't matter which one that goes on top as long as you're consistent. Cross multiplying again, 7.5 times 13, and that gave me 5 times y. I can simplify 7.5 times 13. I just threw it in my calculator. It gave me 97.5, and I had that 5y. So I want to remove that 5, which means divide, and it tells me that y is 19.5. So there's one of my answers. I still need to also solve for X. I'm going to start the same kind of way that I have 7.5 over 5. So I go with what do I know. So I know these two numbers. I'm not guessing. I didn't round anywhere. So I like to go with what I know the best. And then I took the 18 and the X. Again, 7.5 from the big triangle to the little, from the big to the little, being consistent. Again, cross multiply. So 7.5X is 18 times 5. So one step of simplification, 7.5x is 90. I divide by 7.5 and I got that x was 12. All right, so hopefully you're getting the gist of it, so let's keep going. I want you to try one now that we've done a couple examples together. Let's have you try one on your own. Always I want you to pause the video, write this down on paper, see if you can solve for the x and the y, and then of course come back and check it and see how you did. Okay, so here's the work. I said when I looked at these, I knew the bases, 16 and 6, so that's where I wanted to start. So I compared 16 over 6 and then y over 12. I cross-multiplied, so that gave me 16 times 12, 192, and then 6y. So I could divide by 6 and get 32. So let's try to do the same thing and solve for x. So again, 16 over 6, and then my 24 over x. I cross-multiplied 16x, 24 times 6. So 16x is 144. I divide by 16, and it says x is 9. All All right, let's try it again. Change the shape, but really shouldn't change your strategy for what you're doing. Go ahead and give this one a try where I gave you two trapezoids. I'm telling you that they're similar, and I just want you to find the value of x. All right, and hopefully you are pausing, then you're coming back. And if you're back, let's look at the answer. So I set up the 40 over 14, so I just did top to top, and then bottom to bottom. Again, the big one on top, this little one on bottom, so I need to do the same thing over here. Cross multiplying 40 times 21 is x times 14. And in these two, I did make the dimensions different. I did feet and inches just to show you that it doesn't matter. It will be consistent because they will cross out. And even here, when I did put them in, you could kind of think, and let me grab a pen so I can kind of mark it out, that, hey, this inch and this inch could kind of cancel out if I were to divide both sides by inches. So my final answer is going to be in feet, which is good because that goes with the big trapezoid that I had. So there, 40 times 21 gave me 840, and I'm leaving the feet in there. And then just 14x on the right, I divided by 14, and I got 60. So there's my bigger, and it makes sense that 14 was smaller than 21, 40 is smaller than 60. There should be little things that hopefully make you feel good about your answer. So let's change up the look a little, and I'll go back and do an example for you. And here it looks like I just have this big triangle, but I have a lot of pieces. I have a 10, I have an 8, I have a 6, and I have an x. And what I want to find is x. So I want you to begin by noticing there are two triangles here, even though it originally looks like one. There's a larger one, right, that goes like this, and I'm just going to try to outline it a little. I know I'm really bad with this pen. So this is my larger triangle, and then I have this smaller one that's inside. So I do have two distinct triangles going on here. So I have one that has a height of 10. Its base would be 8 and 6, which is 14. And then the smaller one is x with a base of 6. So once again, I want to compare height to height, base to base. Okay, so my height 10 to my height x that I'm looking for, and then my base of 14 to the little base of 6. You should see by now this is all about cross multiplying. So I did 10 times 6 is 60, 14 times x just stays there. When I divide by 14, I got 4.29. I got 4.29 from rounding. It didn't come out perfect, but that's okay. Definitely if it was a test on a homework, I will say like how many decimal places I want you to round to. All right, so let's look at a couple application problems. And this one is just because I want you to start with thinking something similar to our last problem. I think this is a very typical question that you could see on a standardized test like an SAT or a GRE. Most of you won't be taking the SAT since you're already enrolled in college, but every once in a while the high school student that may end up taking the SAT later, and I think this will be helpful for them. GRE is kind of the graduate school version of that, so and if any of you guys are thinking you're going to go to grad school one day, which is awesome, just know there's another standardized test that you take to get in there. Part of it will be mathematics, and they love this kind of problem I'm getting ready to give you. So it usually sounds like this. A 6-foot tall person standing 18 feet away from a building has a 9-foot long shadow that ends with the shadow of the building. How tall is the building? Okay, so I did my best to represent this with a triangle here, and it kind of reminds me of the last one where I have this outside triangle and I have an inside triangle. So the height of the building, I don't know. I called it X, and then I threw a person in here and said they're 6 feet tall, and they were standing 18 feet away from the building, and there was a shadow that the man had. I'm assuming it's a man because it's 6 foot. Totally could be a woman. Sorry about that. The 6 foot tall person, I guess, is what I should say, is 9 feet away, and they're ending together. So again, I have height to height. So I have x over 6, and then I have height, or I have this base. So 18 and 9, 27 compared to the 9. Okay, so height, height, base, base. Cross multiply. 9x, 27 times 6. So this 9x I can keep. 27 times 6 would be 162. Notice I had feet, feet, feet. I kind of crossed one of them out, which left me with 1 there in the answer. You could always just put the dimensions on at the end. That's absolutely fine. I just wanted to show you what they could look like if you wanted to keep it in there. So my last step, I did 162 divided by 9. I got 18 feet, so that says here's how tall the building is. All right. One more application, as I thought we'd talk about a map. So here on the map, I added this ABC to the map and said, hey, if the map, the distance between A and B is 11 centimeters, and the distance between A and C is 8.5 centimeters. I want to compare this and say, well, the actual distance between A and B is 14.2 miles. How far is it from A to C? So I can measure on the map and say, hey, what if I happen to know how far away A and B were for real, and I was trying to figure out how far A and C were because maybe I just didn't have that information, and I know you guys have GPSs in your phones, but every once in a while they're going to be out of range or out of something where you just don't know. So let's say, how would we figure it out? Right. So it's still similarity, it's still a proportion, and what I'm going to do is compare A to B. So A to B is 11 centimeters on the map, but we said it's 14.2 miles in real life. And then A to C was 8.5 centimeters on the map, and we don't know what it is in real life, so let's figure it out. Cross multiplying, I have 11x is equal to 8.5 times 14.2. So that gives me 11x, and then it says 8.5 times 14.2 is 120.7 miles. Now, I just want to, again, show you what I did with these conversions of, or not really conversions, but what I did with these dimensions is I said I had a centimeter, and I had a centimeter. I could cross those out, and my answer will be in miles. So this 120.7 I divided by 11. Again, I had to round it a little bit, but that's fine. Tell me x is 10.97 miles.